Hello, my name is Carl. Welcome to my workshop and welcome to my YouTube channel. This is just a quick video. This is going to be Rover Gas Turbine 11, and it is just a quick look at some of the components that I've removed yesterday from the gearbox. And I also managed to get the armature out of the housing yesterday as well. So I'll show you all the components that I took out, and we'll have a look at the bearings and a discussion about what we're going to do with those. So I hope you enjoy the video. So as I said in the intro, I dismantled the gearbox last night and I wanted to show you some of the parts. A lot of the gearbox dismantling was intricate and quite difficult to film, although I did manage to film some of it. And a lot of it I had to actually work through the camera because I was using it for magnification. So I'll try and show you some of that. I'll stick some of that in now after this sort of descriptive section or narrative section. The buzzer's been going all day today, so we got the armature out last night. So this is what it looks like. Here it is. So you can see there, look, there's the commutator and the windings. This end is the business end, the drive shaft, the output side. So that sort of keyed sleeve, if you like, that fits onto the drive feature on the other end in the housing. This end has got like a key on it, and that's for the brake disc, which I'll show you now. So the brake disc fits on like this, and that fits over that key, and that drives the brake disc. I did think it was a spline or something, but it's just that key. And then the world's tiniest split pin goes through the hole in there, in that end. And this portion here is what the bearing rides on. Now this is the housing that had the brushes in it, so the brush and bearing housing essentially, and that's where the brake pack was sitting on top of here. So the brake disc kind of fits in like this, if you remember. So the bearing sits in that brass cup, and then the brake disc, this portion of the brake disc here, is the journal for the bearing. So there's the bearing, and I'll show you that in a minute and talk about it. So the brush gear obviously fits in these slots here. I haven't actually cleaned up the brushes yet, or any of the brush springs or any of that. I'm going to do that tomorrow. I got these things, I'll just show you now. These came today, and I was recommended to use these by someone on the MIG welding forum. And these were really good for putting all the small piece parts like screws, nuts, bolts, little circlips and snap rings and washers and thrust washers and all that sort of stuff, distance pieces and whatnot in those. So they were really good for using with the buzzer. So they've been employed today. The cam I'll show you as well in the next part of the video that I filmed yesterday. It's splined. It's in two pieces, so with the splines, and there's a splined distance piece there as well. The splines mean you can adjust the position of the cams on the drive output shaft. Speaking of which, this is the drive output shaft here, look. And in the next part of the video, you'll see kind of retrospectively, I'll show you the stuff I did last night where I dismantled this, and you'll see how this goes in. And there's a little snap ring on there that kind of holds it in place. Typical gearing. These are the gears. This is what they look like. They're just kind of compound spur gear with a pinion pressed into it. And these run on a couple of shafts in the housing, which I'll show you in a second. It's been in the buzzer all day today. So I'll show you that in a minute. The micro switch mounting plate, most of the stuff cleaned up really well. This bit needs a bit more work. The adjustment plate for the other limit switch has got a bit of corrosion residue on it still, so that still needs a bit of work. The buzzer works quite well. I'm reasonably happy with it, but I think some people's idea of cleanliness is not my idea of cleanliness. So I think it works best with a solvent, really. So this is the housing that the gearbox, and as you can see, it's been in the buzzer all day, and some of this stuff is going to have to get very gently abraded off. You know, it's just it's really bad. But fortunately, you know, the fabric of the housing is still intact. That was where the cables ran through, and that's obviously had moisture sitting in there for a long time, and it's really had a good go at it. Some of the anodizing came off with the cleaning solution, so you know it's but you know, we'll probably just paint all this when it goes back together. So these two spigots or bronze shafts, brass shafts rather, are where the gears fit onto, and then the output shaft you'll see runs in that sort of bronze bush. The micro switch housing and the output flange, that's been in the buzzer all day as well. It needs some work. I think a Dremel and a little brass brush or brass wire wheel is going to be the order of the day for that. I mean, you can see on some of this, there's some, the corrosion has really had a go at it, especially you can see here, look, where it's kind of, I'll zoom in on that. This bit here it is particularly bad. You know, it's really eaten into it there. That's a really big pit, and you can see the edge there, and that's a really good example of crevice corrosion, essentially where these two components have been fitted up like this, and that kind of locating spigot there, or this locating feature, has been inside there, and that's allowed moisture to sit in that gap. There's no jointing compound or anything being used, so moisture sat in the gap between those two parts, and it's just ferreted its way into there. There was probably a tiny little nick in the anodizing at this point here, maybe where someone's used a screwdriver to pry these two parts away from each other at some point in the past, and it's got in there, and it's gone for its life. I've had a lot of success in my recent engineering work that's not aircraft related. I've had a lot of success with anodized components that have been exposed to seawater, and I've had a lot of pitting when you can't get spares for them. I've had a lot of luck with actually abrading the corrosion out to fresh metal and then filling it in with aluminium putty, kind of double bond stuff, hair metal, whatever you want to call it, and then kind of machining it back to a sound smooth surface again, which you can do. Once that stuff's set, you can machine it. So that's what we'll do to repair this, because the chances of getting another one of these are, well, practically zero. So we'll do the same thing inside there as well. You can see the state of that. All that needs to be cleaned out very carefully with a little brass brush in a Dremel, or even just Scotch-Brite. So that'll be a job that needs to be done in the near future. Right, so we're still on with the Rotax actuator, and I want to get this gearbox disassembled so that we can get this housing into the buzzer, because I've got the other corroded parts ready to go in the buzzer now, so I want to get everything in one go. So this is the input gear, and as you can see, it's just a bog standard kind of compound spur gear train running all the way through. And what I really like about the design of this is, if you see that pinion there and that one there, they're actually the output pinions, and they're driving on the opposite sides of a gear, which is the main output shaft gear. So that's a nice balanced drive you've got there. So even torque on both sides of the gear, which is nice design. I like that. So what they would probably use nowadays, instead of this little clip, is one of those little E-clips, which is maybe what we'll use when we reassemble it. So I've managed to get the small screwdriver underneath it there, look, an even smaller one here, and there we go, it's off. There it is. Let's get the good job it's magnetic, isn't it, that? Right, that was interesting. Okay. So that gear now lifts off, and I think it's got a little bush in it as well. Oh, looks like that's brass actually. That can go in the box. So that's all the gears off now, and they're all covered in, I'll show you, they're all covered in basically what just looks like dried grease. There's two shafts that the gears are borne on. That's the output gear there. And then we've got a snap ring down below the cam that you can just about see. And another one on here. So I've just managed, with a pair of picks to remove that snap ring there, which was lying on top of that washer. And the snap ring was in the circumferential groove there on the output shaft, which is integral with the gear. And it turns out that the cam was actually in two pieces and was splined onto the shaft. So that's interesting, isn't it? That implies that you can adjust its position on the shaft. Well, it doesn't imply, you can adjust its position on the shaft. But anyway, we'll get all this stuff now into the buzzer. So this is a really awkward shot to get. I'm holding the light and I'm holding the camera as steady as I can. You can see there the two field coils, and down there, like, you can see where the armature shaft engages into that sort of spigot that's sticking out of the bearing. You can just about see the bearing, and you can see the circlip that's holding it in, and you can also see all the corrosion products in there. And I mean, it looks like growth. It's that bad. Trying to get it to focus properly so you can see it, but yeah. But I think those field coils are going to have to come out in order for me to extract that bearing and clean the inside of there up, without a doubt. So this is the bearing that I removed from this housing, from that brass cup there. If I can get it to focus, there you go. So that sits inside there, and as I mentioned earlier, the brake disc is the journal, sits in there. It rides on this portion of the brake disc. So you can see here it's a Hoffman bearing. It's 1/2 inch OD, 3/16 ID, and 5/32 width. So I've got these on order. The one at the opposite end is the same. So I haven't got it out yet, but I know it's the same. So I've got a couple of these on order from Bearing Boys. But this is absolutely ropey as anything. It's just rough as a badger's backside, basically. No wonder it didn't work. It's just really difficult to turn. It's almost seized solid. And the one in this end, I was having a go earlier on, and I'll show you a bit of video of it, of trying to get this apart. Well, the idea is I'm going to have to take these the pull pieces out, the field coils out, to get access to right down there, which is hard to show you. I've tried to show you it before, but I'll try again from this angle and see if it's any better. See if I can get the light right. So you can see down there. I'll just try and zoom in actually and see if you can see. Just can't get the light quite right and the zoomage. It's not going to work, is it? Let's try and zoom in a bit more. Right down into the bottom of there. Are we going to do it? I don't think so, but you can see the crap that's down there. Look, all that corrosion. And it's gone into the bearing. There's corrosion products inside the bearing as well. And that bearing's even rougher than the other one. I just can't get it to focus properly inside there, but you get the picture. So I've come to the conclusion that these field coils are going to have to come out if I'm going to take this bearing out and clean this properly. If I'm going to take the bearing out of this end, where you can see the pinion. So I've just cleaned out all the detritus from the slot of the screw and around the screw, prior to trying to have a crack at it. Well, that's the end of another one, people, and it's the end of them for quite a few weeks, because I'm going back to work on Monday. It's Saturday evening now, so this will be my last video before I return to work, and I'll be gone for about 4 weeks. So things have progressed really well, I think, with the gas turbine project. They've been a little bit slow with the mill, but I'm going to try and get back onto that mill when I get back from work. Now, you've had a lot of videos from me over the last few weeks. It's been kind of a rapid succession, one after the other. So we're going from kind of feast to famine now. So it's going to go down to 0 for the next few weeks, which unfortunately I'm unable to do anything about. I'm really happy with the progress that's been made with the gas turbine. Really all I wanted to do in this period of being at home was to get it out of its nacelle and get it shifted from the museum into my workshop here. But I've managed to meet and exceed that target, and we've started to make a few inroads. And the thing about the actuator is, it is important to get that done, because at the end of the day, that's how we shut the fuel off when we need to switch the engine off when we do get it running. So it needs to be reliable and it needs to work properly. So it's really been a great I've just really enjoyed working on the Rover gas turbine. At the end of the day, it's something that's worth saving. It's a part of British engineering heritage when all is said and done. And as far as I'm aware, there isn't another one, certainly a 10201 like that one, that out of the Argosy. I've never seen another one on YouTube. I've never heard of another one running. I could be wrong, but as far as I'm aware, there isn't another one. There certainly isn't another one on YouTube that's where the refurb is being documented as I'm doing. And if you go and look at some of Whittle's early drawings and early patents, you'll see that there's a direct link between Whittle and Rover. Rover were chosen to do the production work for Whittle's early engines when Powerjets, his company, was first producing the prototypes, and it was done at Barnoldswick in Lancashire, and Rover were involved with Whittle right from the outset. And when you look at the compressor, impeller, and the turbine in the engine that's sitting down there just behind me now, and you look at Whittle's early drawings, they're very similar. I mean, they're almost identical to the Whittle unit, the first turbine that he built. So, we've got a piece of genuine British engineering heritage in this workshop. So, it just blows my mind. One of the things that I've been thinking about doing, and I'd like to get your views on this, is I'm going to try and open up a Ko-fi page that's linked to my channel. Now, I've really thought about this hard, and I've kind of wrestled with my doubts about it a little bit, because asking people to donate money to me to help me out when I'm doing things, it almost feels like begging a little bit. But there's a lot of expense going to be coming down the road where the engine's concerned, especially if I need to get spare components that I can't make myself, or if we need to buy tools or materials or whatever else. So I'm still haven't made the decision yet. I'm still considering whether I'm going to go down the Ko-fi route or not. And for those of you who are uninitiated, what that means is that should you choose to make a donation to my channel, it gives you a mechanism by which you can do that. And you can donate whatever you like, as a small amount as you want, and every little helps, as they say. So do give me some feedback on that. Let me know what you think. And so basically, that's it for the next few weeks. Thank you very much for subscribing to my channel. Thank you very much indeed for commenting and for giving me a like. Please do give me a like. That really helps. It really does seem to be helping. I know it sounds, everyone says it, but for some reason it does seem to work. If you're not subscribed, please do consider doing so. It doesn't cost you anything at all, and you'll get to see what goes on with the mill and with the gas turbine as well. As soon as I've done it, you'll get to know about it. So until we meet again, take care of yourselves, and I will see you all on the next one.